Okay. Net force is applied to an object that's at F cosine theta. Weird. Along the displacement. Okay, I guess. Displacement. Well, it says it's along the displacement, so whatever. Work is force times distance, which means area. If we need that. If we have a speed and a place, what's the mass? Okay. So work also equals change in kinetic energy. So does it start from rest? At rest. Okay. Which means the whole change in kinetic energy is the total kinetic energy, because like final minus initial, final will be like something and the initial is 0 because it started at rest. So change in kinetic energy this time equals final kinetic energy, which is handy. So if we find the area, we can say the work equals the final kinetic, force times distance equals the final kinetic. So the area equals the final kinetic energy. So area equals 1/2 mv squared. The area of this is 1/2 base times height, because that's a triangle. That's on your formula sheet, so you actually don't have to memorize that. The height is 10, 50, 50. This is 10 by 10, so that's 100. Don't put 20 by 10, because it's just the second part. So the area is 150 equals 1/2. The mass is what we're looking for. And the velocity is 14. Square. Okay. I have no idea where my calculator is. Probably you get 1.53. Okay, just for y'all, I got my calculator. And you do get 1.53. So that is the answer, 1.53 kilograms.